I just wanted to today talk about something that ERICO has called transient discriminating technology. To take a little bit of the mystery out of surge protection, I'll give you a bit of history. When I started in this game as an engineer working as a designer of surge protection products about almost 25 years ago now, the products were colloquially known as MOVs in boxes, so a MOV in a box technology. And it's very much a metal oxide varistor inside a canister of some kind, plastic or back in those days mostly metal in fact. What that meant was it wasn't the sophisticated or the type of product that we have familiar with now with a few bit more bells and whistles and certainly a lot more safety stuff in there. What we discovered in the early to mid 90s when the surge protection industry was barely a decade old was we were starting to see switchboard fires caused mostly due to premature aging of those metal oxide varistors. They're kind of like a decent sized PN junction, and over time they will degrade. And when they degrade, they quite often fail to a near short or a short circuit, and interconnecting wires get quite hot, insulation catches fire, switchboard fire. So, as I said, after about a decade of the industry being really putting a lot of product out there, we had to have a good look at ourselves, start writing some safety standards and designing in some features. I'm going to take you through one of what we think is the more important feature right now from a safety perspective. Basic surge protection products, what we really need to start with, a good surge rating. This is a performance indicator, gives you an idea of how long the product will last in the field. One of the other main criteria for design, a low let-through voltage. We're very much trying to control the voltage coming in through the switchboard out to the load. Now these voltages are not 50 hertz over voltages, they're surges, very short duration, sometimes only a few microseconds at a time, but quite often very high magnitude, some tens of thousands of volts in fact, but very short duration. Now this defines the performance of the device, but doesn't really speak to the, I guess, safety feature of the device. Will it survive the surge? Will it inhibit any short circuits or any of those fires that we were talking about earlier? Those sorts of things, that premature aging that I was talking about, is caused by what we would know as a temporary overvoltage. So it's a 50 hertz overvoltage, maybe for a few cycles or a bit longer, that exists on that input feed. And that, I can tell you right now as a surge protection engineer, is death to the metal oxide varistor. It kills it very quickly. It's designed to handle very short durations, not 50 hertz overvoltages. So the first thing we did was put in some thermal fusing. If the MOV got hot, we disconnected it. But we then had a product that was no good for the market. It needed replacing. All right? So what do we do? Well, this is where our transient discriminating technology comes in. The sine wave you can see is just, as I said, a superimposed, just an overvoltage condition. You can see the little red dots are where that metal oxide varistor, the voltage is exceeding its clamping voltage and it starts to get quite hot, and ultimately it'll catch fire. That's why we put that thermal fusing in. As I said, the next step was to make a device that would ignore that overvoltage and only come online to protect your load equipment when there was a genuine surge there. So that short duration, higher frequency event. Here's the two circuits we're talking about. The older one is on the left. There's a bank of metal oxide varistors in parallel with some thermal fusing connected in series. The one on the right is our transient discriminating technology. The switch you can see above the bank of MOVs is a TD switch, frequency dependent switch. So it's open circuit for 50 hertz. When we get an overvoltage, it's a short duration, it connects those MOVs into the circuit and limits that surge voltage. All right. All we've done is improve the performance of the device by making sure it does nothing for 99.9% of the time. In that one moment where it's actually needed, it's ready to go. It hasn't been degraded by those overvoltages. Pretty much what we're showing here with these graphs. The top one is our standard, where the MOV will eventually catch fire due to an overvoltage and not be there to capture the surge later on. The bottom graph is our marketing illustration. You can see that dotted line is a higher 50 hertz clamping voltage, and the lower voltage when it's needed at the surge is that short duration spike. We rolled this technology out back in the late 90s into an existing product line called our MOVTech. This has been around since I'm guessing the mid-90s perhaps, when we first rolled out the MOVTech. Still in the marketplace today. We still can't shift some customers like Telstra away from these very durable, very, very robust bits of kit. Lacks a few bells and whistles. So what we did about a dozen years ago was develop a modularised product that is packaged up in various forms. That's pretty much what we're showing there. It's a TDX100M. Those same TDX modules, those transient discriminating suppressor modules, can be used in 200 kA devices, 50 kA devices, so for main switchboards, very exposed main switchboards, down to dB level, smaller products as well. But the same building block, same MOV, thermal fusing, and transient discriminating technology. The idea is that you then have a module that is a spare that a client can keep on his maintenance cupboard, that he can plug into any of those as those sacrificial components wear out. But we don't actually sell that many modules as spares because they're actually just a very, very durable product these days. Using our standard surge protection module with an LC filter as well. All we're doing is that large voltage we have coming into our main switchboard, we're limiting it even more by putting a low-pass filter in there. This isn't an RFI filter, it's actually a low-pass filter. It's 50 hertz voltages only coming through. These sorts of devices are wonderful. They'll literally, for most of the performance, will be about half the voltage of a normal shunt protection device, which is just that MOV in a box type thing. These things with that LC low-pass filter will bring it down by, in some cases, several hundred volts lower. So again, your more sensitive loads, distribution boards for file server rooms, security systems, these sorts of things, hospitals and so on, more sensitive loads. There's your single-phase filter. Again, you can see the shunt protection modules at the front end and your LC, so your inductor and capacitor low-pass components at the back end. Start at about 3 amps and up to 2,000 amps. Okay? You have to rate them by load current. Unlike those earlier photos I showed you, the shunt protection modules, these actually sit in series with your load because you have that series connected inductor. So size them according to your circuit breaker, basically. In closing, I should say, thank you to Lee Wilkinson from ACES, who's our channel partner for Erico Global here in Victoria. Thanks, guys.